Welcome to video lesson number 5. Today's lesson is on ratios. For this lesson, of course, you'll always need the notes you were given in class, TOC number 5. You need a pen or pencil to take notes, a highlighter, marker, colored pencil to highlight keywords, and for this lesson, it is part of the non-calculator section, which means please put away your calculators. All right, let's get started on the notes. A ratio is a comparison of two different things. And there are 3 different ways to write ratios, and we're going to go over those in just a second. Ratios can either be a comparison of the part to the part, a part to the whole, or a whole to another whole. So the 3 ways that we are going to learn how to write ratios. The first one is obviously a fraction, your favorite thing in all the world, I know. And in this example, the part would go on the top and the whole would go on the bottom. Sometimes we compare parts to parts, and so whatever is given to you first would go on the top in the numerator, and whatever is given to you second in the sentence would go on the denominator. One thing to remember, that the fraction always has to be simplified. Yes, your favorite thing to do. Let's look at this example on the right. What is the ratio of shaded stars to all the stars? So in this example, we have 5 shaded stars, and if I were to count all of them, I would have 10 total stars, and so my fraction is going to be 5/10, which when I divide both sides by 5, simplifies to 1/2. You can also write a ratio using a colon, and that is those 2 dots that are on top of each other that you see in English class, and English is coming into math. So that's just an abbreviation that we can use to show a ratio. Now, first thing you have to do is simplify your fraction so you know the simplified ratio. But the numerator is going to go on the left of the colon, and the denominator is going to go on the right, or what was given to you first goes on the left, and what's listed second goes on the right. So let's look at this example. What's the ratio of triangles to hearts? Well, in this example we have, highlight simplified fraction, please. Back to the example on the right, we have 4 triangles, and we have 3 hearts, so our fraction ratio is 4/3. We cannot simplify that. It's as simple as it can go. So now let's just take it and write it using a colon. So the numerator goes on the left, 4, colon, and then the denominator goes on the right, 3. Pretty easy stuff. The last way that we are going to learn how to write ratios is using words. And the key words that we use when we're identifying ratios is the word to, or sometimes you'll see it as out of. With the word to, it can be any kind of comparison, part to part, part to whole, or whole to whole, but with out of, it's always going to be a part comparison to the whole. So I did make a mistake. On number 2, it should say write the second item after the word to. So they're going to give you a sentence. The first thing goes before, the second item that's listed goes after. We're going to look at that in just a second. And for all ratios, the order that it's given to you when it asks for the ratio is important, because that tells you which number comes first, and that's with fractions, with a colon, or when you're writing it with words. So look at the example on the right. The example says there are 18 footballs and 10 basketballs in a ball bin. What is the ratio of basketballs to all types of balls? So in this example, even though they gave you footballs first in the problem, they're asking for basketballs. So this is what we mean by the order matters. So there are 10 basketballs, and in order to find how many of all, you have to add them together. So 18 plus 10 gives you 28. So because they asked for basketballs first, that goes in my numerator, and my total goes in the denominator. So this is part to whole. If we simplify it, then we would divide both sides by 2, or both numerator and denominator by 2, and I would end up with 5 over 14, or 5/14. So when I write it, I would write 5 to 14 is the ratio, or 5 out of 14, because it's talking about the part that is basketballs to the total or whole number of balls that are in the bin. So on the back side of your notes, we're going to continue with the definitions and the vocabulary. So as we were saying, a ratio is a comparison of two numbers by division. Please highlight division. It doesn't look like division, but that's what that fraction bar means. It means divided by. And it can be written as a fraction, and most of the times ratios are written that way. It compares the part to another part or to the whole, and then you have to simplify. A rate is a special kind of ratio. It's a comparison of two measurements having different units. And some examples might be how many cups per boxes, or how many miles that you walked per hour, how many dollars per gallon, things like that. So the key word that you're going to hear when you're talking about rates is per, because it's comparing the two units. A special kind of rate that has been simplified is a unit rate, and it's a rate that's been simplified so it has a denominator or bottom number of 1. And to find the unit rate, it's important that you highlight this. All you have to do is divide the numerator by the denominator. And this is often used when you're in the grocery store to find the best deal, or to compare prices, or when you're talking about the speed that you're traveling. Everything is MPH, which stands for miles per hour. So it's telling you how much you're traveling per hour. And then the last thing we're going to talk about is a proportion, and that is a statement that says that two ratios are equal. And we use these, actually you've been using proportions, you just didn't know that's what they were called, to find equivalent ratios or equivalent fractions since you were in elementary school. So let's look at the middle part of your paper. Here's some examples of ratios, and we're going to just simply find the simplest form. So in the first one, I have some pictures of soda cans here. And what if we said 18 out of the 45 cans of soda that we bought for an event are Pepsi? We would write that as a fraction. 18 is given to us first, so it goes on the top. 45 is given to us on the bottom, that's the total or the whole. And then we have to simplify. So I'm going to divide those both by the greatest common factor, which in this case is 9. I could have also divided both by 3. I just have to do it a couple times. And when I do that, I get a simplified ratio of 2 out of 5. So for every 5 cans of soda, 2 of them are Pepsis. Another example is 15 out of 75 pencils. So if I say 15 out of the 75 pencils that I have in my possession are colored pencils, or have different colors, then that's how I would write it. It would be 15 on the top, 75 on the bottom, and to simplify, I'm going to divide both by 15. That's my greatest common factor. I also could have divided both by 5 if I didn't know that 15 would go into both numbers. And then when I divide both by 15, I get 1/5. So that means out of every 5 pencils, 1 of them is going to be a different color. Here's another example, but this one is not a part to a whole comparison. It's part to a part. So they're saying that I have 155 apples and 75 oranges. So I could write that as a fraction with 155 being on top in the numerator and 75 being in the bottom. One thing you're going to notice with ratios is you do not make them a mixed number. It's going to stay an improper fraction. And that's because if you were to make it a mixed number, that whole number that goes out front, you wouldn't know which one that goes with. So we keep ratios always as improper fractions or top heavy, however you want to remember that. And for this one, I'm going to divide both of them by 5 because that's my greatest common factor. And I would simplify to 31 over 15. So whenever I have 15 oranges, I'm going to have 31 apples. And the last example for regular ratios is I have 32 out of 64 calculators that are brand new. And so I would write that as 32 over 64. And then I want to simplify that. And if you didn't recognize it, 32 is actually the greatest common factor because it simplifies to 1/2. So half of all my calculators are new. All right, let's talk about unit rates. And remember, unit rates are a specific kind of rate that compares two different units. So in this case, we have dollars and DVDs, and we have pages per hour. And one thing I want you to highlight is whenever you're doing a unit rate, always put the money in the top in the numerator. So let's look at our first example, number 5. We have $25 for 3 DVDs. I want to know how much am I paying for one DVD so that I know if I'm getting the best deal at this store versus another store where it's selling it per DVD. So our first step is to write them as a rate, which is 25 over 3. And to find the unit rate, to make the denominator 1, I'm going to divide both the top and the bottom by 3. When I do that, I am going to get a decimal, and that's okay. You end up getting $8.33 for one DVD. So that allows you to see how much am I paying for one, so I can compare the prices at one store to another store to figure out if I'm getting the best deal. Another example may be if you're comparing how many pages you can read in an hour. So in this case, this student reads 10 pages in 2.5 hours. So we write that as a rate, 10 over 2.5. And in this case, with ratios, you can have decimals in your fractions, and that's okay. So to find how many I'm reading per hour, I need to divide both the numerator and the denominator by 2.5. And I end up figuring out that I am reading 4 pages per hour. In number 7, I'm driving in a car and it took us 5 hours to go 250 miles. So I write that as a rate, 250 over 5. I'm going to divide by the denominator, which is 5. And I figure out by doing that that we were driving 50 miles per hour, or 50 over 1. So every hour we're driving 50 miles. Last example for unit rates, we have 4.5 miles in 25 minutes. I'm riding my bike. So I write it as a rate first, and then I'm going to divide both by 25 because we divide by the denominator, and that tells me that I am going 1.8 miles per minute. All right. So let's look at the last little example. Yours is in black and white, but mine's in color, so we can simplify these fractions. What is the ratio of stars to all shapes? This is a part to whole comparison. So there are 4 stars, and there are, if you were to count them, there should be 16 total shapes, because you have to include the stars along with those. To simplify, I'm going to divide both the top and the bottom by 4 because that's my greatest common factor, and I end up with 1 out of 4. So 1 out of 4 shapes are stars. Next one says, what is the ratio of stars to circles? Well, there are 4 stars, so that goes on the numerator, and if there's 16 total shapes and 4 of them are stars, then I could subtract to figure out how many circles there are, which is 12. Then I'm going to divide by the greatest common factor, which is 4, and I end up with 1 over 3. So there's 1 star for every 3 circles. And the last one says all shapes to circles. Since all shapes is given to me first, it goes in the numerator, which is 16, and we already knew that there were 12 circles, so now all we have to do is divide. We're going to divide both by 4. That's our greatest common factor, and so we would end up with 4 over 3. Now it's time to show what you know. Don't forget to log back into the student notebook and click on the quiz link and go ahead and take the little homework quiz to show us what you understood about ratios.